let's get started. So we are doing week 4, and week 4 talks about stacks and queues. So let's just jump to that. So I have a couple of pictures in there of what a stack is and what a queue is. So the abstract data types, right, which is basically the real world problem that we're trying to solve, are the stacks and the queues. Okay, so what's a stack? The easiest thing to think of is just a stack of plates, right? Whenever you're going to add a new plate on the stack, you push it on top. Okay, so there's only a couple of operations that are possible on the stack. You can either add a plate on the top, you can remove the plate from the top, and you can look at the plate on the top, right? Adding the plate on the top is called pushing, removing the plate from the top is called popping, and looking at the plate on the top is called peek. So those are the 3 different things. And the queue is just another word for basically a line of people. And how does the line of people work? Well, you have somebody all the way at the end. That's the last person to arrive, and you have somebody all the way at the front, which is the first person to arrive. And we add people at the end and remove people from the front. Okay, so these are 2 different algorithms. The first one for the stack is last in, first out. Okay, so the last one that you added is the first one you remove. And the algorithm for a queue of people is the first one that you added is the first one that you're going to remove. And let me turn off the light a little bit. Okay, so and how we're going to build these fancy data structures in Java, we're going to use arrays again. Okay, so what we're going to do is we're going to have an array, we're going to encapsulate it inside of a class, and we're going to restrict how we can add and remove things to that array. And that's basically it. Now, there are defined objects inside of the Java language. There's a stack object, there's a queue object, and depending on what author you look at and where this class is taught, they might actually use that built-in, structure that's part of Java. Okay, that built-in object. We're not. Okay, what the author, what LaFour does is he basically builds the whole thing. He'll show you how to build this stack, how to use the stack. So we're going to focus on actually building them and creating them. They're not very complicated. You're going to see. It's just basically you're going to have an array, but you're going to restrict the operations that you can have on that array. Okay. Let's have a look at this little thing that I have in here. All right. So this is pretty much the book, right? Stack 4 queues, right? And it talks about how you're going to be using arrays to use these stacks, and there's some analogies that he uses about, like, okay, we're going to have a stack of envelopes. The first one that you put is the last one that you're going to remove, or the first one that you're going to remove. For me, the plates kind of makes a little bit more sense. There's a lot of different applications for stacks. So if you're doing the assembly language, there's going to come a point, or maybe you already got to it, but you're going to realize that the way functions are called, whenever you call a function, you're placing it on the stack, and then you're pushing it on the stack, and whenever the function returns its value or it's done, you're popping it off the stack. That's how it keeps track of things in memory. Another application of this is, let's say you have some kind of an equation, right? You have curly brackets, parentheses, and then maybe square brackets somewhere in there. How does the compiler know whether you have a matching set of parentheses? Well, it uses a stack. It pushes them on the stack and then pops them off the stack, and if they don't match, you have a problem. Okay, so the main thing is, Let's have a look at this. Okay, so let me just jump to this here. Okay, so let's have a look at, first of all, the stack, which is part of the book. See what it looks like. Okay, so we have a stack, a class called stack, which has, you know, a size, how many things are going to be on that thing, on that array, right? That's what this is. And then to add elements to the stack, you're just saying stack array top is equal to element to push. So the element to push is the thing that you're trying to add. Top keeps track of where you are, right? So if you have, let's say you have something like, let's say, what do we call it? Stack array, right? And then we have declared this thing to be of 4 different things. So we have 1, 2, 3, 4. Okay. So initially top is equal to -1. Okay, but as soon as you try to add something to this, right, what happens to top? You do plus plus, so now it becomes equals to 0. So the first thing that you're going to enter is maybe this. Okay, as soon as you do that, right, before you even do that, top is equal to 0. You add something, you want to add something else, top increases by 1. All right, so initially top is equal to 0. Right, here top is equal to, sorry, initially top is equal to -1. And then when you add something to it, at this point, top is equal to 0, right? And then as soon as I try to add something else, top goes to 1, right? So it goes 1, and then I make stack array top is equal to element to push. So let's say I wanted to go and add a 20 in there, right? So that's how it works. And then if I wanted to add another one, right before we add the other one, top goes plus plus. So now top is equal to 2. And let's say you want to add, now you're adding the new element, which is the 30, for example, right, etc., etc., etc. So that's a stack. Okay.
You have to set the top -1 or
this here. You can make it equal to 0, and then you can do this afterwards. So you could have, you could make this equal to 0, and then you can do this after. That will work too. Does that make sense?
What's the difference though?
Well, the difference is, okay, top initially starts at -1, right? So if I increase top by +1, initially it becomes 0, and then I insert the value, right? Then let's say I want to go and insert another value. It was 0. As soon as I get to this line and I'm trying to add another value, it becomes equal to 1. Does that make sense?
So it directly reflects the index.
Yeah, top is the index where you're inserting things. So if you want to start it at 0, you could start this at 0, but just don't increase this here. Increase it after you add the thing, right? And increase it after you have pushed something on the stack. Right? So you can start it at 0 and then increase it afterwards, or the way that the book is doing is he starts this at -1. And then as soon as you add the first thing, the -1 goes to 0, and then basically you're saying, okay, this 0 is equal to the new element. Then you're going to go and do another element, right? Let's say you're trying to add the second one. Top was 0 before. Now it's going to go to 1. So you're telling it, 1, right, is equal to the next thing you're going to add, which is the 20. Does that make sense?
Yeah.
Okay, so that's what happens. So yeah, top is just basically the index of the top. Okay, and then yeah, it's so the all the way at the end. This is the top. So if I'm going to be removing things, look at the pop. Okay, so by the way, the pop returns the thing that we're removing from there, which is going to be stored in element to pop. Right. So let's say we have this construct right here. We have 10, 20, 30 with these indexes for top. In here, I say element to pop is equal to stack array top. So array is top is what? Top is 2. So I'm telling it, okay, get the 2, put it in here, and then get rid of top -1. Basically, top goes here. This thing is still in the array, okay, but it's just the marker that tells us which one is the top changes. So we still have the 30 in there. If I wanted to add something else, I would just overwrite this to some other number. Okay? And the maximum number of things that I could add is max size. That's basically fixed. It's part of my stack object. Okay? So that's how the pop and the push works. And the peek is you look at top element. What is the top element? Oh yeah, top element is equal to stack array top. And again, if you have two things, then this is the top. If you have one thing, then this is the top. If you have three things, then this is the top. Make sense? Yes? That's it. That's pretty much all there is. And then there's a way for you to check to see if stack is full or if it's empty, right? So if top is equal to -1, that means we never added anything. If we're checking to see if it's full, if top is equal to max size -1, then it's full, otherwise it's false. And that's all there is. Any questions? So stacks are not complicated. There's nothing fancy about them, right? You just
So the max size -1. In this case, it's a 2. And
so the max size here, max size is equal to, if I have, let's say 4, right? Then the biggest one for top to be is 3, right?
Okay.
So if my top is equal to max size -1, then we fill the thing up. Okay. So that's it. So all it is, it's an array which is encapsulated inside of a class, and we restrict the possible operations that we can have on this array to just add at the end of it, remove from the end of it, and look at the end of it. And that's it. And how's the end of it marked? Using top. Okay, so that's a stack. Okay. Let me just jump to this thing real quick. He's got some applets in there. There's your sample program in there. Some pictures to go with it. Okay, you can have a character array. It does not have to be just an integer stack, right? You can have a character array. The stack construct that's part of Java can take on any kind of a data type. You can have a stack of objects. You can have a stack of integers, stacks of doubles, whatever. But it's pretty much implemented the same way. Okay, there's something in Java and in C++ called templates, and using templates you can basically make a class or a method to accept any data type. So you can make something work universally for any data type, and that's how it's implemented. But to keep things simple, we're just going to use just basically a character array or a string array or an integer array. Okay. Another thing is, so one thing that they're showing in here is basically how you can check to see if, I don't know if I have it in here. No, I don't. Basically, what you have to do is, let's say you have some kind of a thing, right? So if it's any kind of a special character, so basically you have different kind of things that can happen. You can have like an if, right? So if it's this curly bracket, or if it's this parentheses, or if it's the square bracket, push it on the stack. If it's anything else, don't, right? So we would push this, we would push this, we would push this, and then if it's the other kind, if it's the other way, we would start popping things, okay? So what you're going to do is, if you pop a thing, and basically this, if you encounter this, basically you pop, okay? And if whatever you pop happens to match this one, but just the opposite side, then it's balanced equation, right? Then so I have pushed this, I have pushed the curly bracket, right? I push the curly bracket, I push the parentheses, I push the square bracket. Then I encounter this, that will be a pop, right? As soon as I encounter the opposite side of the square bracket, not the left one, but the right one, I'm going to pop whatever I have on my stack. And if whatever I pop happens to be the opposite of what I have encountered, we have a match. Then I go to the next one. As I encounter a parentheses, as soon as I encounter my parentheses, the next thing I'm going to pop is, I have already popped this one, so now I'm going to pop this one. All right, so this one matches this, and I still have a matching equation. Right? Then I go to the next one, I encounter another curly bracket, which is basically a trigger for pop, and then I'm going to pop the next thing, and if the next thing that I'm popping happens to be the opposite of this right curly bracket, then you have a balanced equation. If at any point you say, oh, I encountered this and I'm going to pop, and then you end up getting like a square bracket, that's not a balanced equation, right? Let's say I wanted to pop this, but I end up encountering this square bracket. That means that this one was missing, right? And it's not a balanced equation, okay? So that's one practical purpose of stacks, okay? And there's some example code in there also for you to look at, right? And those are basically the different cases, right? So if it's any of these cases, if it's curly bracket, square bracket, or parentheses, you push, right? But if it is anything else, then you pop, okay? And the thing that you're pushing, or you have pushed, is the CH. The thing that you're popping is the CHX, and then you're just checking to see if they match. Okay. So basically, and it's right here. So if you have the thing that was if you have the thing that was popped is this, and the thing that was pushed in is this, or it wasn't this, then you get an error, and otherwise it's good. Okay. Just to see if it's balanced. Yeah, if every set of parentheses has a closing, right? If you open a parentheses, check to see if it's closed. If you open a square bracket, check to see if it's closed. Okay, so that is basically the practical application of stacks. You can use them to reverse things. You can use them to store things in memory. You can use them to check to see if an equation is balanced. There's also like a postfix and prefix notation. So basically, if we have a bunch of, like, say, A plus B is our regular notation. You can have plus AB, that's the prefix. You can also write this thing as AB plus, that's the postfix. There's ways for you to basically figure out the arithmetic if it matches and if it's balanced also. Okay, so this is stacks. Very easy stuff.
When you say balance, what do you mean balance?
I mean, if you have matching,
Character.
yes, correct. Okay. And there's some examples in there. Look through this also. Conceptuate. Okay, so that's Q. Okay, so now the next thing is Qs. I might post another. I have another PowerPoint from another book. I think I'm going to post that too, so you can see what it looks like. Okay.
For the stack,
Yeah.
make it empty instead of copying each one. Can you just write another routine?
Well, you could. Sure.
Just move the pointer and do it pop, 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 pop. Just move the pointer. Or
Well, you are moving the pointer.
well, you're doing a.
You're moving top.
One of the stack is not empty.
Yeah.
Top.
Yes.
Right, yeah. You just say, make a new routine. Make empty.
Well, that's what is empty is. Is empty checks to see if your top is equal to -1.
I don't want to make it empty.
You could, sure. Yeah. But generally speaking, the operations that we want to limit a stack to is push, pop, peek. That's it. Yeah.
So
Sure, you can.
Default, like, clear the stack.
Sure, you can do whatever you want. Yeah, it's in the rig. You can insert any way you want too. By the way. Yeah.
What would you typically use the stack for, like in terms of real life?
Memory. Yeah. You're pushing something on the memory, like you're calling a function, you're pushing it on the stack, and then as soon as the function ends its magic, then it returns, and then you pop it off the stack. And that's why, sometimes you get stack overflow and that kind of stuff. Our favorite forum for all things programming.
It's
Okay.
like hackers try to mess with.
Yeah. Hackers will force the stack to overflow, and then you can look at things. Yeah.
Is that a DDoS attack? When
Denial of no.
when they
may go on, let's say, Amazon and
Yeah.
just send data, massive amount of data.
No, I don't. I wouldn't call that a stack. Stack is like when you're doing something with memory. That is basically the denial of service attacks are basically you're giving so many requests all at the same time to the server that it overwhelms it. You can't handle all of them. Okay, so that's that. And again, I'm not like exactly a security specialist, so yeah, I'm kind of out of my element when we're talking about security. All right, so the next thing is a queue. Okay, and the queue is basically also an array, and let's have a look at it. All right, how it is implemented, and this is from the book's chapter. It's from the the same chapter. So it's a class which is a queue. It also has a max size. It has an array. It has a front. It has a rear, and it has a number of elements. Okay, and you could implement this thing without a number of elements just by checking to see where the front and the rear are. But we're going to keep it with number of elements. Okay, so similarly to the stack, when you create a queue, you give it a maximum size. That's how big your array is going to be. And then you're telling it the front is going to be 0 and the rear is going to be -1. Okay, so what we're going to do is, because in the queue, we already saw that in array, we kind of have to shift things all over the place if we want to delete something, and we're going to have to delete things from this, and then when we're deleting things from the stack, all we got to do is we move the top, right? That's the only thing that keeps track of where the last thing is. Now here, what we're going to do is we're going to have a front and a rear, and that's going to have some kind of issues, okay? And the issues are, I put them in this little file right here, queue wraparound issues. So I'm going to download it, and let's have a look at it. Let me close this. Okay, so, and again, this really helps. It helped me to visualize queues. Okay, so start with an empty queue, then start adding to it, and then try to see what happens to these different variables. What happens to rear, what happens to front, okay? So we are at, let's say, insert, okay? So what we're going to do is, we're going to run into some issues, and let's see it right here. I guess that will help you understand it. Okay, so let's say we're inserting something. Okay, so I have my original array of 5 things. Okay, I have not inserted anything yet, which means that by default in the constructor, front is equal to 0, number of items is equal to 0, and rear is equal to -1. Okay, so remember, when we insert something, we move the rear. When we remove something, we move the front. Okay, now the issue is, you're going to see it. So first, I'm adding something, right? So I'm adding my first number. So what that's going to do is, I'm going to say ++ rear. Okay, and by the way, do you remember what is the difference between ++ rear? All right, let's do it this way. So what is the difference between having it this way versus having it this way? So they're both increasing the value of rear by +1, right? But this one, there's a difference between this one and this one. Do you remember the difference? Okay, so this one is basically, let's say my rear, before I get to this, let's say my rear is equal to 0. Okay, what I'm doing here is I'm telling it, go to 1, and then make this thing equal to whatever this is. Okay, so that is if I have it this way. If I have it as this way, then it's basically telling it, okay, use a 0, and then make this thing rear is equal to 1 here. Okay, so when you have a plus after, you're still going to increase rear, but you're going to use it as a 0 for this here, and then you're going to change it. Okay, so what we're doing here is we're telling it increase the rear by 1 before you use it, and then make this thing equal to it. Okay, so bottom line is the user enters some kind of a value j. You want to insert that on the queue, and what happens is you move the rear by 1, by plus 1, and you make it equal to that value j. Okay, so that's what happens here. Yes, so rear starts at -1, and you're inserting the value 10. So now rear is 0, and we inserted it here. So if I wanted to insert another value, let's say the 20, I'm going to do plus rear, so rear is 1, and we're going to make this thing equal to 20. Let's say I want to insert another one, 30. Okay, I'm going to say rear plus rear, so rear is 2, so this is going to become equal to this, etc., etc., etc. So if I want to insert the last one, the 50, right? Number of items is 5 originally, because right, that's the size of the array that I created. So rear is equal to 4. So this is 0, 1, 2, 3, 4, right? So the last one is my rear, and the array is completely filled. Okay, I can't fill it up anymore. It's done. Okay, that's the size of my queue. So now, what we're going to do is I'm going to grab the same queue, and I'm going to start removing things from it. Okay, so it was this. Now what I'm going to do is I'm going to start removing things. So if I remove things, right, my front originally was this. So this is my front, 0. This is my rear, 4. Okay, so now I'm going to remove my front and remove from the front. And let's have a look at where the remove is. And this is what happens to my front. All right, so I do front is equal to 0, so I'm just basically making it equal to 0 so that it's kind of like, okay, now it's empty. And then I'm telling it front, you go 1 to the right. Okay, so front used to be 0, now the front is this one. Okay, then I'm going to go in there, I'm going to tell it, okay, remove the next one, which is basically just make it equal to 0. Oh, sorry, no, right here. Make it equal to 0. And front moves by 1, so now it's 2. Okay, then I say, all right, well, then remove the next one, remove the 30. So now this is your new front. Okay, and so far it's all good, right? It works out nice. Okay, and notice we're not shifting anything, because I mean, ideally or not ideally, but what I could have done is I could have grabbed this thing here. I could have put the 40 here. I could have had the 50 here, and then I could get rid of this, right, and this. You could do that, right? But then that would make it more or less efficient, because you're going to have to shift these, right? You would have to shift the 40 and the 50. You're going to have to shift these things all the way to the left. So you're going to have to move a whole bunch of things. You're going to have to swap things. So we don't, all that to eliminate all that shifting, which can be very time consuming, especially if you have a queue of objects which are huge. They take up a lot of space in memory. So instead of shifting things around in the array, what we're going to do is we're just going to shift the actual pointers, the rear and the front, right? And it works out great up to this point, okay? But now what? Let's say I want to, so at this point, my rear is this one. Actually, sorry, this is the rear and this is my front, right? So the front is the 40, the rear is the 4 or the 50, okay? So now what happens? Okay, so what I'm going to do now is, so this is front, this is rear. So if I wanted to add a new element, where am I going to add it? I can't add it to this side. It's already all the way at the end, right? So let's say I want to add a new one. Let's say if I wanted to add 60, I'm going to have to go and shift my rear pointer, which was right here all the way at the end. I'm going to tell it go all the way to the front. So if I want to insert a 60, it will go here. Then if I want to insert a 70, it will go here. So the wraparound issue is that when your rear, which is all the way at the right is your rear. When it gets all the way at the end of the array, you have to tell it go back to the beginning of the array. Okay? And that's the wraparound issue. Okay? The wraparound issue is as soon as you get to the end, right? So rear is equal to full, which is at the last index of the array. How do we know the last index of the array? Well, you use max size, right? Max size is it's a variable which is part of your queue object, and it indicates how many things we have. If your rear is max size minus 1, that means you're at the end of the array, and what are you going to do? You're going to make the index. You're going to make the rear now equal to 0. Right? So I'm going to insert my 60. The rear, which was 4, or max size minus 1, now becomes equal to 0. And that is the purpose of, where's the insert? This right here. Right? So when my rear gets to the end of the array, I'm going to say the rear is equal to minus 1, just like I did up here in the initial thing. And then when I insert something, I say plus plus rear, so this thing goes from minus 1 to 0, so now it's the 0. Make sense? Any questions? If it doesn't make sense, look through this code, take your time. It does take some time to sink your mind into it.
But if that's the case, and if you don't remove the item, it's gonna override the new.
If you try to keep adding things and it's already full, well, it should be. Ideally you should have something in the insert that checks to see if this variable and items is equal to max size. So we could keep track of how many things are in the queue, and then if we have as many things in the queue as the max size, then don't add. So we could build that in there. It's just not in this code for simplicity's sake. Actually, no, the end number items is there. We're just not really using it. But yeah, ideally on the insert all the way on the top, you should have if number items is less than max size minus 1. Okay? That's the ideal thing you want
And
to do.
if the front is not equal to 0, because we're using the 0 index, you're going to start overwriting data.
Well, the front and the rear, they move automatically as we need them to. Right? So let's go back to the Word
So
file.
no, I'll just have the scenario where you you start loading it.
Mhm.
Let's say you had an array of 4, but you have 5 items. If there's not a condition there, it's going to overwrite index 0, correct?
If you have not removed them, they're not zeros. That does not change. So the only time number items changes is if we basically zero out these different elements. All right. So the only way this thing is not full is the only time this thing is full is it was full right here. Where was it full? Right here.
Right.
So it's full when number of items is equal to 5, which is your max size. So that's the regulator. Okay? All right. But it isn't full, right? So now we actually this was the situation, right? This is my front, this is my rear. Now some other person is going to come. We can't add the 60 here. Where are we going to add it? We're going to add it right here. And now we're going to force the rear to go to this. So this is my front, this is my rear. I want to add another one. I move my rear by 1. I want to add another one. I want to increase my rear by 1. So this is 0, 1, 2. This is my rear, and this is my front. Okay, and again, the only reason we're doing this is so that we don't move things around. We don't shift so many elements to make this thing more efficient. Okay, so this is my rear, this is my front. Okay, so 0, 1, 2, 3. Okay, so then what I'm going to do is I'm going to remove some things. So we still don't have an issue, right? So I'm going to remove this one. Now my front is a 4, and then I'm going to remove this one. As soon as I remove the last one, what I have to do is I have to deal with that wraparound issue, right? These two no longer exist. So now this is my front and this is my rear, which means that I have to move the rear from where it was, which is the 50, to 60. Okay? So in other words, when your front gets to the end, which is basically number of elements minus 1, right? Or max size minus 1. Then you make it equal to 0. And this is in your remove. Where's the remove? Right here. So if my front goes all the way to the max size, make it equal to 0, and then remove the number of elements. You're removing the number of elements regardless, basically. Okay? And again, what you could do is, again, to make this thing perfect, which it isn't really, is you don't want to be removing from an empty array, right? If it's already been emptied out, which means that if number of items is 0, then don't add anything, or I mean, don't remove anything. Okay, so this is the wraparound. So when my front becomes equal to my max size, make it equal to 0, and reduce the number of items after that, regardless. Okay, so this is basically the wraparound issues of queues, and one implementation of queues. Or so far, what you've seen is all these have been implemented with arrays. Okay, but very soon I'm going to introduce you to linked lists, and then when we get to linked lists, you're going to see that this same thing that we did can be done with other ways other than arrays. And then when you have a linked list, then you can expand and contract this thing without having to worry about, you know, shifting things so much. Okay, because deleting from a linked list is very easy. You just remove the link, reconnect the one before to the one after, and you're done. You don't have to shift a whole bunch of things like an array. Okay, so this is the main thing here, the wraparound issues. The other thing is, let's see what else I have. Yeah, so we have 2 assignments to go with this. Assignment 5, assignment 6. Assignment 5 is, go look at the book. Project 4.2, create a double-ended queue. Oh, and I forgot to mention, you could have a double-ended queue. What is a double-ended queue? You can add and remove from either side. So now you have to, now at this point with the queue, you had one kind of a wraparound issue because you're only adding and removing one way. But when you do double-ended queue, which means that you can add and remove from each side, now you have to deal with a wraparound issue on the other way, right? Because you could be adding on left, you can be adding on the right, you can be removing from the left, you can be removing from the right. So you have to deal with another set of wraparound issues. So it's important for you to understand how this works before you can do the other one. Okay? One other thing that I didn't mention is we also have something called a priority queue. And what is a priority queue? You're basically inserting an order. Right? So different things have different priorities. Like say if you have a stack of envelopes or whatever, you're going through your mail, like maybe the most important thing goes on top or something. Right? So the order in which you insert things in the queue matters, which for me it makes the easiest way to explain this is if you're trying to insert something in order. Like let's say you want to have a queue that's, you know, sorted in ascending order. You would insert in a specific order. If you have 1, 3, 4, 5, you have to insert the 2 after the 1, right? Etc. etc. So if you're trying to insert a 6, it's going to go after the 5. If you're trying to insert a 0, it's going to go before the 1. Okay, so if the order in which we're trying to insert things matters, then that will be a priority queue. Okay, and again, this is something that we're going to do with linked lists. I'll test your understanding of linked lists, because when we do linked lists, first I'm going to show you linked lists. Okay, this is fun. Then we're going to do another week on linked lists. I'm not sure if we do 2 or 3 weeks on linked lists, but at the end, I will ask you to do a double-linked, double-ended priority queue with linked lists. All right. So all this that we've learned, you're going to have to implement it with linked lists. So make sure you get it. Okay. So what is a double-ended queue again? You should have an insert left, insert right, remove right, is empty, and is full methods. Okay, so the is empty and is full is pretty much, I think we already have it in the sample program. What you have to do is you have to add all these insertions, one extra insert, one extra removal. Okay, so that's the first one. And the next one is a stack. And I think for the stack, I just have you do something pretty, let's see. Should have the same method as yeah. I should have all the same. So it's pretty much use the example to write your own stack class. Maybe I should have added a little more to it, but I'll leave it like that. If you're taking the 46 class, I'll have you do things like reverse. So maybe what you can do is you can have a stack of words, stack of letters, and have the user type like a hello world, and then use the stack to pop things and reverse it. That's something that you can do. So the main thing is read through the chapter, get comfortable with these two different constructs that we encountered now, the stack and the queue. They're really not that complicated. I think the only complicated thing is this wraparound issue, and the rest is just playing around with arrays. So a lot of this you will see as we go throughout the semester. A lot of times I'll tell you, okay, here's the idea, this is the abstract data type queue, and this is how we're going to implement it. This is a data structure using an array. And then later on I'll tell you, okay, now we're going to use a different data structure with a linked list. So there's different ways to implement these abstract data types into data structures, and a lot of times it just makes sense to do it with an array first, because that's what we know. And there's a reason. That's the reason why I also don't use vectors. We could have a vector which expands its size or shrinks its size based on how many things are in it. But in order for you to understand how it works, I think it makes sense to just do it with arrays. Okay, and the author of the book does it that way too. Okay, and again, there's some other, computer science data structures classes that they don't really focus on the actual implementation of these data structures, but it's more about using them. For me, I think it's more important for you to understand how it's built, how it works, the underlying fundamentals of these data structures, than just you import stack from Java and then throw a bunch of things in it. Okay, so that's all I have for week 4. Next week, question?
The double queue, is it like you make 2 keys?
Double-ended queue. Double-ended queue is, so if this was your original queue where people join at the end and leave at the front, the double-ended queue means that they can join at the front also, and they can also leave at the end also. So it's basically a queue where people can come and leave from either end, from either side. That's it. That's a double-ended queue. Yeah. And then next week we're going to start talking about linked lists. All right. Linked lists, your little introduction to linked lists is next week. Then I'm going to tell you, so 3 weeks. First I'm going to show you about linked lists. Then I'm going to tell you about circular lists. Then I'm going to tell you about double-ended linked lists, right? Which is basic, and it's going to be a priority queue too. Okay, so basically everything that you can possibly do with a queue, we're going to do that with a linked list. So if you're not comfortable with linked lists after 3 weeks, I'm going to quit my job. So you're going to get linked lists, right? And why am I focusing on linked lists? Because they're one of the most used data structures. Even these binary trees and stuff like that, and heaps, they're pretty much kind of like linked lists in a way. So that's one thing that I really emphasize. So that's it. That's for week 4. And any questions? Come see me in the office hours. I'll be here if you need me. Send me your emails.